This is probably the image you first think of when you hear the word nuclear. Or this. Or even this.
This is the worst day ever.
Hi, Homer, what gives?
Mr. Burns is making me eat all these drums of toxic waste.
And this all seems really scary, but what you really should be thinking of is this. Hi, I'm Ben McKenzie. I'm just a 12th grade student who's trying to spread positive information about climate change. I personally think that nuclear is pretty cool. Contrary to the pop culture depiction of it, nuclear power is actually a very safe and clean form of energy production. Nuclear power is a great form of power generation. It's definitely better than fossil fuels and does have its perks over renewable energies. Nuclear power has no emissions like fossil fuels and is very flexible, meaning that it's able to be turned on and off independently of the weather, like renewables. There are many benefits to replacing fossil fuels with nuclear power, but why don't we do it? The reason is simply due to the public's fear of it. Germany recently shut down their last nuclear power plants as of April 15, 2023. Since the 1980s, Germany has been on a campaign to reduce the amount of nuclear plants in the country. I personally think that this is a step in the wrong direction, as in order for Germany to produce the same amount of energy, they need to burn more fossil fuels. Yes, Germany is also investing a lot more into renewables, but the main issue is that they're putting more things into the air that are actively killing us. My goal with this video is to try and show you how much of a positive asset nuclear power is to us, and also to use facts and logic to destroy those nuclear myths. But before we get into the benefits of nuclear power, it's probably beneficial for you to know how it actually works, since a lot of people don't actually know. Nuclear energy doesn't have some sort of sci-fi energy collection technology. It's actually really simple. We boil water. That's it. Okay, fine. I'll go into a little bit more detail. Yes, we do make water boil with nuclear power. But how do we boil that water, and how does that turn into electricity? Well, as you probably know, everything in the universe is made up of atoms, but these atoms are made up of even smaller subatomic particles called protons, neutrons, and electrons. The protons and neutrons hang out in the center of the atom in a place called the nucleus. The bonds here in the nucleus are so high that it's really, really difficult to separate them. But if you are able to separate them, there is a massive amount of energy that gets released from that. And that is the basis behind nuclear power. After the bonds are broken, neutrons shoot out and hit other atoms, which causes a chain reaction of more and more atoms releasing energy. And this process is called nuclear fission. By sticking fuel rods of fissionable material into water, we're able to use the energy from fission in order to heat that water up to 320 degrees Celsius. The water in a reactor is highly pressurized, so it doesn't boil. And we send this water through pipes to a steam generator. And in the steam generator, the heat from the pipes boils other water, separate water, and causes that to turn to steam, which then rises and is condensed into a small area where it spins a turbine. And these turbines can spin up to 1,500 times a minute. And by spinning the turbine, you're converting the mechanical energy into electricity, which can then be sent out into the local power grid. Overall, nuclear power is a pretty simple process. It's honestly not that different from how coal and natural gas plants work, just a different fuel source. Now, we don't just let these reactions just go on and on all by themselves all day, right? We have safety procedures in mind. So what are some of the safety features that are in place in these reactors? So what are some of these safety features that are in place in plants? Well, the first safety feature helps us control that fission reaction. In order to keep the reaction going steady, yet still being controlled, the solution inside of the reactors isn't pure water. It's also mixed with boric acid. When fission occurs within these reactors, 3 neutrons are released. The boric acid helps reduce the amount of neutrons that are released and go off and hit more atoms. So it helps slow down that chain reaction. The second safety feature within these reactors are control rods made up of boron or other material. These help stop the reaction by physically lowering into the water if something starts to go wrong. Because of the material that they're made of, they also help absorb spare neutrons that are released from the atoms. And by lowering all of the control rods at once, you were able to stop the reaction within 1.2 seconds. So now that you know how nuclear power works, you're probably wondering what makes it any better than fossil fuels. The main and biggest reason why nuclear power is such an asset is because it's a much cleaner source of energy. This means that the amount of waste generated by these reactors is significantly smaller than fossil fuels. The amount of nuclear waste that has ever been generated in the entire 70-year history of the industry comes out to about 500,000 tons. And I know that sounds like a lot, but when you compare it to the yearly emissions of fossil fuels, it doesn't even come close. In 2021 alone, the world produced 37 billion megatons of greenhouse gas emissions. Needless to say, it's clear that nuclear energy takes the win in this area. Another thing that nuclear is just better at is its flexibility. This basically means that nuclear doesn't rely on external factors in order to produce its own power. Unlike renewable sources of energy, solar, wind, hydro, nuclear doesn't need the environment to be cooperating, it just makes that power anytime you need it. But one of the most clear places that nuclear energy wins is its energy density. The amount of energy that nuclear power generates is absolutely insane to think about. Just quickly, how much coal do you think it would take to match 1 kilogram of uranium? If you said 1 ton of coal, you are insanely off. In order to match, 1 kilogram of uranium's energy density, you would need 1 million kilograms of coal. Uranium is literally 1,000,000 times better than coal. Because of this energy density, nearly 20% of the US's energy comes from nuclear, despite the fact that there's only 59 nuclear plants in the US. Comparatively, the US has 224 coal plants and a staggering 1,500 natural gas plants. There is no other form of energy generation which even comes close to the efficiency that nuclear power provides us with. So once again, this is another clear point in the nuclear corner. Now that I've laid out the clear benefits that nuclear provides, why don't we use it as our main source of energy production? If we go back to the 60s and 70s, nuclear was seen as this bright future technology and had high support all over the place. So what happened? Well, simply, people became scared. Nuclear is a word people hear and think of uncontrollable radiation, green goo in rivers causing mutations, and of course... Oh my God! Now, I'm not saying people don't have a right to be scared. It's good to be skeptical, especially of something that you don't completely understand. I'm just here to tell you that you shouldn't be as scared of nuclear as you are. So, one of the first things people think about when you bring up nuclear power is nuclear waste. Contrary to popular belief, nuclear waste isn't some sort of malicious green goo that corrupts everything that goes near it. People expect it to be in these barrels, and if it falls out, everything goes into chaos and you get three-headed fish and death claws and instant deaths being around these things. But the truth is that nuclear waste is pretty safe. Nuclear waste is mostly solid material, which is only very slightly radioactive and won't hurt you unless you get really close to it. On top of it all, nuclear waste has a very short half-life, which means it decays pretty quickly. Most low-level nuclear waste made by plants decays in about 100 days. We don't just let the waste sit around and decay all willy-nilly like. We melt it down into glass and ceramic, and then we store it in large cement silos. These silos have walls made up of 20-inch thick, high-density concrete, and are lined with thick steel plating on the outside. In these silos, the waste stays cool and decays safely, and any radiation coming off of it isn't able to make it out of the silo. These silos can be made on site of nuclear power plants and are able to contain the low-level and medium-level waste. High-level waste has a very long half-life, making it not very safe to store on site, which means it has to be transported somewhere else. Traditionally, this sort of waste has to be kept in deep depositories underground. These depositories range from 200 meters up to a full kilometer underground, making them some of the most isolated places on Earth. They're so far underground that seismic activity doesn't really affect them, making them incredibly safe spaces to store nuclear waste. They're also separated from any groundwater, meaning that no water is contaminated by them. Underground depositories are a proven method of storage, where all the high-level waste can go and decay safely over its half-life. But that brings us back to our question: how do you get this high-level waste to the depositories? The answer to this question is heavily armored nuclear flasks. And when I say heavily armored, I'm talking Hulkbuster levels of armor. Like, you are not cracking these. These behemoths of cargo transport are made up of multiple layers of protection. The outside of these are made up of 15-inch thick steel, and underneath that is a layer of lead shielding, which protects any radiation from leaking out of these things. Effectively, these things are indestructible, and when I say that, I really mean it. Hell, we ram trains into these things for product testing. And to top off our little section about nuclear waste, transport isn't even that necessary. The only reason we really need to transport nuclear waste is to bring it to these deep depositories. But what if there was a way to do that on site? Well, if we leverage the technology that the oil and gas industry has given us, we're able to drill really deep holes into the ground using oil drills. And then we're able to fill up these holes with nuclear waste rods. And once again, these things are so deep and isolated that they won't affect anything up on the surface, even if there is seismic activity. With these points in mind, I hope I've convinced you that nuclear waste isn't that big of an issue, and also that we have the solutions to deal with it right now. The other thing people are pretty afraid of about adopting nuclear power for is nuclear accidents. And let me preface this by saying, yes, nuclear accidents are bad and they are dangerous, but they weren't necessarily as bad as people make them out to be. There are 3 incidents that people bring up when they usually talk about nuclear accidents. 1 being 3 Mile Island, 2 being Fukushima Daiichi, and 3 being Chernobyl. Starting off with 3 Mile Island, how many people do you think were actually hurt in the incident? The answer is no one. No one has ever been recorded as being directly killed by 3 Mile Island. And even after thorough research after the accident, no detectable rise in health issues has ever been spotted. Even the workers in the plant on the day of the accident had no detectable long-term health effects. I can't exactly get into the nitty-gritty of what happened on that day, but if you want to know what actually happened on the day of the accident, Kyle Hill has a great video on the subject. The Fukushima Daiichi incident is a similar story, albeit it has larger consequences. The accident was a result of a nuclear meltdown following a magnitude 9 earthquake on the coast of Japan in 2011, and the following tsunami, which was the single most devastating event in Japanese history since World War II. The aftermath of the tsunami left 12 out of 13 backup generators for the cooling systems out of order, which led to meltdowns in reactors 1, 2, 3, and later number 4. The radiation of the incident was estimated to go 60 kilometers away, and an exclusion zone of 20 kilometers was established around the plant. Despite all of this, every report made after the accident puts the number of deaths directly caused by Fukushima at a whopping 0 people. Even after the second worst nuclear accident in history, 0 people had died as a result of it. The damage to the marine life in the area was negligible, and the people closest to the plant received radiation doses not that much higher than background. It's also important to note that the accident only occurred due to the 4th largest earthquake in recorded history, an incident that was going to be pretty hard to plan for regardless of how prepared you were. The main point I want you to take away from this is that despite Fukushima being the second worst nuclear accident in history, doesn't hold a candle to Chernobyl or even the natural disaster that caused the accident to occur in the first place. Speaking of Chernobyl, the poster boy of nuclear disasters, it was an absolutely horrible event. The event was mostly caused by poor management, cost-cutting measures, and worst of all, a complete lack of containment building surrounding the reactors. This would have prevented the spread of radiation if a situation like this would have occurred. Had there been a containment building on the day of the disaster, it's likely no lives would have ever been lost during the accident. Chernobyl was easily preventable, but it did happen, and I can't exactly say that it wasn't a big deal. The effects of the incident can still be felt today, with the exclusion zone surrounding Pripyat still being too dangerous to be in for a long period of time. But what I can say is that the 4,000 deaths caused by the Chernobyl accident seems minuscule when you compare it to the 8 million deaths caused by air pollution in 2018 alone. Often when we talk about fossil fuels, we only talk about the climate changing effects of it, when really, air pollution is the silent killer that people think radiation is. Exposure to air pollution increases your chance of stroke, respiratory illnesses, as well as trachea, bronchus, and lung cancers. And if for whatever reason you're okay with pollution, but radiation is where you draw the line, you'll be happy to know that burning coal releases radiation as well. Burning coal releases 10 times the amount of radiation that a nuclear power plant makes in a year to make the same amount of energy. The ash let out from coal plants contains significant amounts of mercury, arsenic, lead, thallium, uranium, and thorium, which, if you didn't know, aren't that good to be around. And we probably shouldn't be putting that in the air. And just for clarification, nuclear plants do not release radiation into the air. If you remember from earlier, the steam generator is a completely separate loop from the reactor loop, meaning that there is no chance for radiation to leak out into the air. All the waste from nuclear power plants comes in the form of solid material, which, as we discussed, is very easy to contain. On the topic of radiation, that's another one of the main reasons people are opposed to nuclear power. Radiation is a scary thing. It's one of the most harmful things a person can be exposed to, so people have a right to be concerned with the amount that they're being exposed to living around a power plant. The yearly amount of radiation that is recommended is around 50 millisieverts. A 6-hour flight will expose you to about 0.035 millisieverts, and having an X-ray will be about 0.1. And just being exposed to cosmic background radiation, which is radiation you get just for existing, exposes you to about 1.2 millisieverts a year. So how much radiation do you think living around a nuclear power plant exposes you to? Well, according to the Canadian Nuclear Safety Commission, living within just a few kilometers of a nuclear power plant will expose you to just about 0.001 millisieverts a year. That means going to the doctor for a broken bone is more dangerous than living around a nuclear power plant. Hell, just existing exposes you to more radiation. The amount of radiation you're exposed to living around one of these bad boys shouldn't be anything of concern. And even if you work inside of a power plant, the amount of radiation you're getting is negligible, only about 1 millisievert a year, which is 0.002 a day. So once again, flying across the country is still more dangerous for you. One last thing before we wrap all of this up. Explosions. One of the main things people are afraid of with the word nuclear is obviously nuclear bombs. With how devastating atom bombs are, it's once again very understandable why people have a right to be concerned with something like that happening anywhere near them. But the important thing to note is that an explosion of that magnitude happening is literally impossible to happen. The uranium used in nuclear fuel rods isn't enriched nearly enough to be used as a weapon, meaning that it's impossible for a nuclear power plant to explode the same way an atom bomb would. Some people are concerned that terrorists would be able to get their grubby little hands on nuclear fuel rods or waste and be able to turn that into weapons. Once again, this is a non-issue. As I said before, nuclear fuel rods aren't enriched nearly enough to be used as weapons, and same can be said for nuclear waste. The only way terrorists would be able to turn these into nuclear bombs is if they had access to the very expensive enrichment process and also had enough uranium to turn the 3% purity used in fuel rods up to the 90% purity used for nuclear bombs. And if an organization has access to that, they're probably a government. So just to recap, people's fear of nuclear power is understandable. It's good to be scared of things that you don't entirely understand, but that doesn't mean that the facts back up these feelings. Nuclear waste is actually pretty safe to store, and the transport of it is a non-issue. Nuclear accidents are incredibly unlikely and much less damaging than pop culture would have you believe. Radiation exposure is negligible when living around a power plant. Going on a flight or getting an X-ray exposes you to much more radiation. And finally, the chance of nuclear plants going critical and exploding like an atom bomb is 0%. With how safe nuclear power plants are to actually be around, it's a wonder we're still using fossil fuels when those are actively making us sick and making our planet sick. With all the benefits of nuclear power, its energy density, flexibility, and lack of emissions, I truly believe nuclear power is the right way to go for our energy needs. At least until renewables are able to catch up, and then we can truly be a sustainable society.
We live in a society where the corporations are trading coal money for the environment. Yeah.
See, look, I'm going to do the YouTuber thing and direct them to other videos I made. If you want to learn more about renewable energy and one way which we can increase our solar capabilities right now, watch my other video about solar glass windows. Thanks for watching this video I made. I think it's pretty okay, and I hope that you do too. No.